In 1998, two independent teams of astronomers made a shocking discovery. The universe is stretching, but not evenly. Some parts of the universe are stretching faster than others. At first, they thought it was a fluke. Maybe their instruments were at fault, or maybe there was some unknown systematic error in their data. But as more and more measurements confirmed their results, astronomers realized that something strange was happening out there in the cosmos, something that they couldn't explain. And it's been baffling scientists ever since. So today we're going to get to the bottom of this. We're going to find out why the universe is stretching and if it will tear itself apart. I'm from the channel. This is a story of modern cosmology. 13 billion years ago, the Big Bang occurred and our universe, with everything in it, started expanding from an extremely hot, dense state. Over billions of years, the universe has expanded and cooled. Stars and galaxies have formed and moved apart. And we know that because light takes time to travel, the farther away an object is, the farther back in time we can see it. Looking into space is like looking back in time. When Hubble launched in 1990, one of its first images was of a cluster of galaxies known as the Hubble Deep Field. 24 years later, Hubble returned another image of the same patch of sky. And what they found was that the galaxies had all moved apart. It was the first clear evidence that the universe was expanding. In fact, when Edwin Hubble discovered this, he formulated what's now known as Hubble's law. The farther away a galaxy is, the faster it's receding from us. The further away, the faster it's moving. But then, in the late 1990s, those supernova teams noticed that something was off. They'd assumed that the universe was expanding at a steady rate, but their data showed that distant supernovae were too bright. That meant that the light from these explosions had been stretched by the expansion of the universe, shifting them towards the red end of the spectrum, making them look older and much farther away than they should be. If the universe was expanding at a steady rate, these supernovae would have been redshifted more, meaning they'd appear even more red and even more distant than they actually were. They weren't. The only possible explanation was that the universe isn't just expanding, it's accelerating. As if that wasn't strange enough, the deeper into space they looked, the faster the expansion seemed to be. It was almost as if empty space itself was getting more and more stretchy. And this brings us to today's big question: what in the world is going on? Scientists call the force causing this accelerated expansion dark energy. And despite decades of searching, we still don't know what it is. One idea is that dark energy is a property of space itself. Just like space can be curved by matter, maybe it's also inherently stretchy. Albert Einstein was the first to suggest that empty space could have some kind of energy to it. His theory of general relativity says that space-time is curved by matter and energy. But in 1917, he tweaked his equations to include a constant that could represent a kind of anti-gravity that could counteract the effects of gravity. He hoped this would allow him to have a static universe, one that didn't expand or collapse, but it turned out the universe didn't need any help staying still. Just a few years after Einstein published his work, the universe went from being static to expanding to collapsing. And then in 1929, Hubble discovered that the universe was indeed expanding, so Einstein abandoned the cosmological constant. But in the 1990s, astronomers came back to the idea, calling the mysterious force dark energy. This is what most physicists believe is behind the accelerated expansion of the universe today. Okay, so the universe is accelerating, but will it rip itself apart? Well, if it does, it won't happen for a very long time. Even if the expansion continues to accelerate, our solar system and the galaxy will remain intact. It might feel like things are getting a bit stretched, but really, we've got nothing to worry about. Other stuff though, well, other stuff is at risk. Eventually, the expansion will stretch and distort galaxies until they fall apart. Around 1 trillion years from now, every star in the night sky will be ripped apart by the expanding universe, leaving Earth completely alone. Well, not completely alone. There would still be the pesky problem of the heat death of the universe, which could happen a few trillion years before that. Or maybe dark energy will cause the big rip, where the expansion gets so strong that it tears apart every structure in the universe. Atoms, molecules, planets, stars, galaxies, nothing will be left untouched. Another possibility is the heat death of the universe, where the expansion causes everything to drift apart, and the temperature of the universe reaches a maximum value. There would be no more stars or galaxies, only dark energy would remain. It's also possible that dark energy will cause the heat death of the universe. Either way, it's pretty clear that dark energy is the culprit behind the stretchy universe. But exactly what is it? Well, that's what scientists are trying to find out. Physicists at CERN are smashing together protons at nearly the speed of light to try and recreate conditions like those just after the Big Bang. They hope that by understanding how matter and energy interact under extreme conditions, they can better understand dark energy and why it's causing the universe to stretch. Meanwhile, astronomers are searching the skies for even more evidence of dark energy, hoping to map its effects more precisely. Maybe one day soon we'll finally get some answers. But until then, we're left with more questions than we can handle. How did the Big Bang occur? Why do stars shine? And why does the universe smell like freshly brewed coffee? Okay, maybe that last one doesn't keep you up at night, but I think we can all agree that the other two are pretty mind-boggling. But here's the thing. Despite how little we understand the universe, one thing is for sure: we are not alone in our quest to understand it. There are thousands of scientists and researchers working on these problems right now. And you can be part of that effort too. That's all for this video. Thanks for watching, and I'll see you next time.